Hello, and welcome to the session on solving difficult linear equations. So what are the linear equations we are going to look in this particular session? We'll first have a look at equations which have unknowns on both sides of the equal to sign. Then we'll look at equations involving brackets. And finally, we'll look at equations involving fractions, fractions on both sides and fractions both on the same sides. Right? So let's get started then. Let's begin with solving equations having unknowns on both sides. Let's look at an equation 5x plus 3 equals to 2x plus 15. Now this looks like a seemingly difficult question because it has x on both sides. So some of us get confused on how to go about solving this. Now, let me tell you that this complicated equations was arrived at from a simple equation like 3x equals to 12. Now, do you know how to solve this equation? 3x equals to 12. That's clear, right? That's easy. We have learned that earlier. If 3x is 12, x will be equal to 4. So we understand that. But now your question would be, well, how was that original equation, which was complicated, having x on both sides, derived out of this simple equation, which is 3x equals to 4, equal to 12, right? This is a one-step equation, whereas that looks like a much more complicated equation, the original one. But let's have a look, okay? So let's start with 3x equals to 12, and let's keep modifying it until we arrive at the equation that we started with, okay? What if I add 2x on both sides of the equation? So on the left, we'll get 5x, and on the right, we get 2x plus 12. And then we add 3 on both sides of the equal to sign. What do we get? On the left, we'll have 5x plus 3, and on the right, we'll have 2x plus 15. And there you go. Okay, isn't it the same equation that we had started with? So let us understand that whenever a complicated equation is given to you, the roots of that equation is always in simple equations. Okay, they have been derived from the simple equations in the first place. What that means is we can just inverse the operations that we did on the right to arrive at the answer on the left. For example, the last thing that we did was plus 3. So on the left, the first thing we'll do is minus 3. So you subtract 3 on both sides. So you'll be left with 5x on the left. And on the right, we have 2x plus 12. Then if you look at the right, the first thing that we started was by adding 2x on both sides of the equation. So the inverse of that is subtracting 2x from both sides of the equation. So if I subtract 2x from both sides of the equation, the left-hand side will be left with 3x and the right-hand side will be left with 12. And there you go. We arrived at the same simple one-step equation, which is 3x equals to 12. From this point, we just have to divide by 3 on both sides and we get x equals to 4. So that was as easy as that. So now let's look at these equations, okay, in a different perspective. 3x plus 3 equals to x plus 7. That's the equation, right? So let's say we have a balancing pan. On one side of the pan, we have 3 x's and 3 ones because that's 3x plus 3. And on the other side, we have 1x and 7 ones. So 1x plus 7, right? So far, so good. Now you should be knowing that if I remove the same quantity from both sides of the balancing pan, it would still balance, right? The equation would still hold. So I'll first remove 1x from each side of the pan. And then I'll remove 3 ones from each side of the pan, right? 3 ones. There you go. So we are entirely left with x on one side of the pan and the ones on the other side of the pan. So 2x is the same as 4 because it has to balance, or x equals to 2. It's as simple as that, right? Now, how do we do that mathematically is the big question. So we start with 3x plus 3 equals to x plus 7, as you can see. Now, what was the first thing that we did? Remember, we removed the two x's from both sides. Removing is equivalent of subtraction. So we we removed 1x from both sides. Remember that, okay? So subtract 1x from both sides of the pan. We are left with 2x plus 3 on the left, and we are left with 7 on the right. What was the next thing that we did? We we removed 3 on both sides of the pan, right? So we subtract 3 from both sides. So we'll be left with 2x on the left and 4 on the right. And now 2x equals to 4, divide by 2 on both sides to get x equals to 2. So this is how we solve, okay, equations involving unknowns on both sides of the equation. Okay, let's take some more example. Okay, 7x plus 3 equals to 3x plus 11. So now on one side we have 7x's, the other side we have 3x's. So the first step is to get the 3x on the left, right? So we remove 3x from both sides. So we are left with 4x on the left, right? 4x plus 3 on the left. And on the right, we are left with 11 because 3x take away 3x is 0. Then we have a plus 3 on the left hand side, which I need to bring it to the right, right? So subtract 3 from both sides. So on the right, plus 3 and minus 3 negates and becomes 0. Whereas on the right, we have 11 minus 3, which is 8. So 4x equals to 8. The last step is to divide by 4. So we'll end up getting x equals to 2, right? So the idea being, if we have unknowns on both sides of the equal to sign, try to get all the unknowns on one side and all the numbers on the other side. Let's try that with this equation. 3x minus 3 equals to 9 minus x. First step is to get the minus x on the right to the left. The inverse of minus x is plus x. So I do plus x on both sides of the equation. So on the right, x will get eliminated. On the left, you'll have 4x minus 3 equals to 9 on the right. Now let's get the minus 3 on the left to the right hand side by adding 3 on both sides. So we are left with 4x on the left and we have 9 plus 3, 12 on the right. So now we have 4x equals to 12. So we divide by 4 on both sides of the equation. We end up at x equals to 3. Right. Let's now look at equations having brackets. Now this is easier than it looks like, okay? Although in current form it is complicated, but all I need to do is expand the bracket and do the same thing as before. For example, if I expand the brackets for the left hand side equation, on the left we'll get 2x plus 6, and on the right we have 5x minus 30. Now this is the same as the original equations that we did, right? Unknowns on both sides of the equal to sign. So let's get started. So we need to first get rid of the 2x, right, on the left and bring that to the right. So we subtract 2x from both sides. So on the left, 2x will get eliminated. On the right, we have 5x minus 2x, which is 3x. So 6 equals to 3x minus 30. Now let's get the minus 30 on the right to the left because we need x's on one side and the numbers on the other side. So minus 30, inverse of that is plus 30. So minus 30 and plus 30 on the right becomes 0. And on the left, we have 6 plus 30, which is 36. So 3x equals to 36, or x equals to 12. Because if I divide by 3 now, I'll get x equals to 12. There you go. That's your answer. Let's try that to the equation on the right. First step, expand the brackets. Left hand side will be 2x minus 8, and right hand side will be 12 minus 3x. Let's get the x's on the same side. So minus 3x needs to be brought onto the left by adding 3x on both sides, right? So minus 3x and plus 3x is 0 on the right hand side. And on the left hand side, you have 2x plus 3x, which is 5x minus 8. And on the right, we are left with 12. Now let's get rid of the minus 8 on the left and bring it to the right, right? Minus 8, the inverse operation is add 8 on both sides. Minus 8 and plus 8 is 0, and 12 plus 8 is 20. So 5x equals to 20. Divide by 5, and x equals to 4. Right? So you should be expert now at solving equations involving variables or unknowns on both sides of the equal to sign. So let's now understand how do we solve equations having fractions. Now, one of the biggest problems in a fraction is the denominator. So your first step should always be to eliminate the denominator. So let's solve the example on the left. We have 5x divided by 2 equals 2x minus 1. What's the denominator? The denominator on the left is 2. To eliminate the denominator, we need to just do inverse because denominators always divide a quantity. We need to multiply by that. So we multiply both sides of the equation by 2. So what happens on the left hand side of the equal to sign is 2 divided by 2, and hence they get cancelled. So you're entirely left with 5x on the left. And on the right, we have 2 times brackets because remember we multiplied 2 to the entire right hand side, which included 2x minus 1. So on the right, we are left with 4x minus 2. So 5x equals to 4x minus 2. Now this is something similar to what we were doing earlier, unknowns on both sides. So let's get 4x onto the left by subtracting 4x on both sides of the equation. So 5x minus 4x is x on the left. 4x minus 4x is 0 on the right. So 0 minus 2 is minus 2. So x equals to minus 2. And there you go. We got your answer. Let's try doing that for the equation on the right hand side. 4x minus 9 divided by 3 equals to x minus 2. As I said, the first step should always be to eliminate the denominator. In this case, the denominator is 3. So I can eliminate it by inversing the operation of division, which is multiplication. So I'll multiply by 3 on both sides of the equation. What that does is on the left, 3 divided by 3 is 1. So the 3's get cancelled. And on the right, 3 gets multiplied to the entire right hand side, right? So x minus 2 entirely gets multiplied by 3. So we are left with 3x minus 6. So your final equation will be 4x minus 9 equals to 3x minus 6. Now this is back to the same form, okay? Unknowns on both sides. First, let's get the 3x on the right from to the left, right? So I'll subtract 3x from both sides. On the right hand side, 3x minus 3x gets eliminated, 0, right? And on the left, we are left with 4x minus 3x, which is 1x, x minus 9. And on the right, we have a minus 6. So x minus 9 equals to minus 6. The final step, obviously, is to transfer the minus 9 from the left to the right. The inverse of minus 9 is plus 9. So we add 9 on both sides of the equation. On the left, minus 9 plus 9 is 0. So we are only left with x. And on the right, we have a minus 6 plus 9, which is 3. So x equals to 3. Right. What if the fractions are on the same side of the equal to sign? Okay, we have two fractions. Now, once again, the thumb rule for adding or subtracting fraction is always they should have the same denominator. As long as you understand this principle, life is simple. So let's look at the example on the left. We have two fractions, one with a denominator of 3 and the other one with a denominator of 6. Is it possible for us to equate the denominators of both fractions? Yes, right? We can turn the 3 into a 6 by multiplying by 2. But remember, in a fraction, we can't just multiply the denominator by 2. In order to convert into an equivalent fraction, we need to also multiply the numerator by 2. So the first step would then be to multiply and divide the first fraction by 2. So what do we get? In the numerator, we have 2x plus 8 because we multiply the entire numerator by 2. And the denominator would be 6. So the equation would be changed to 2x plus 8 over 6 plus x plus 1 over 6 equals to 2. Now that both the fractions have the same denominator, we can easily add the numerators, leaving the denominator the same. If I add the numerators, I'll get 2x plus x, which is 3x, 8 plus 1, which is 9, correct? Divided by 6 equals to 2. 3x plus 9 divided by 6 equals to 2. Now, this is like your 2-step or 3-step equation now. This should be easy now. First, let's get rid of the denominator 6 by multiplying 6 on both sides of the equation. 6 divided by 6 on the left cancels, left with 1. And on the right, we have 2 times 6, which is 12. So 3x plus 9 equals to 12. From here on, journey should be easy. Let's transfer the plus 9 from left to right by doing a minus 9 on both sides of the equation. Correct? So 9 minus 9 is 0 and 12 minus 9 is 3. So you're left with 3x equals to 3. Divide by 3 and you get x equals to 1. Let's try doing that for the fractions on the right hand side. The denominators of the fractions are 2 and 6. Is it possible for us to make the denominators equal? Of course, yes. Okay, we can always multiply the first fraction by 3, right? 3 times 2 is 6 to make it 6. So the denominators will be equal. But remember, we need to multiply numerator and denominator both by 3. We can't just multiply the denominator by 3. In a fraction, we need to multiply both numerator and denominator by the same number. What will be left with? The numerator would be 3 times x, 3x, plus 3 times 2, which is 6, right? 3x plus 6, denominator will be 6. Now, with the denominators being equal, we can easily subtract the two numerators, leaving the denominator the same. So we are left with 3x plus 6 minus x minus 2. Okay, be mindful, this is a potential scope of error. Many students leave it as a plus 2, but remember there was a minus sign. That minus applies to both the terms of the numerator. So we have minus x and minus times plus 2 is minus 2. Let's combine the like terms in the numerator. 3x minus x is 2x and 6 minus 2 is 4. So 2x plus 4 divided by 6 equals to 3. Next step, let's get rid of the denominator 6 by multiplying by 6 on both sides. The 6 divided by 6 on the left is 1. And on the right, we have 3 times 6, which is 18. So 2x plus 4 equals to 18. Things are easy now. Now, right? You should be able to see the answer from now. Plus 4. Transfer the plus 4 on the right-hand side by doing a minus 4 on both sides of the equation. So we are left with 2x equals to 18 minus 4, which is 14. 2x equals to 14. Divide by 2 on both sides. You get x equals to 7. Right? So even if these equations looks complicated, by following some simple principles, okay, you should still be able to get the answers. What if we have fractions on either side of equal to sign? Now, we have a denominator of 2 on the left-hand side and a denominator of 5 on the right-hand side. The thumb rule for such equation should be find the LCM of both the denominators. So what's the LCM of 2 and 5? It is 10. So the first step should be to multiply by 10, which is the LCM of the denominators on both sides of the equation. Why do we do that? You'll know now. Okay. On the left, 10 divided by 2 is 5. And on the right, we have 10 divided by 5, which is 2. So now this ends up being your simple equation with brackets on both sides. Remember, we had done that questions. So on the left, if I expand the brackets, I'll get 5 times 3x, which is 15x, minus 5, right? 5 times 1. And on the right, we have 2 times 6x, which is 12x, plus 2 times 5, which is 10. So 15x minus 5 equals to 12x plus 10. It's back to the same form where we have unknowns on both sides. So let's subtract 12x on both sides, right? Remember, we need to get the 12x from right to left. So the step is subtract 12x from both sides. On the right, 12x minus 12x is 0. So you're left with entirely 10. On the left, we have 15x minus 12x, which is 3x minus 5. So 3x minus 5 equals to 10. Let's now transfer the minus 5 to the right-hand side by adding 5 on both sides, right? So if I add 5 on both sides, on the left, minus 5 plus 5 is 0. So you're left with only 3x. And on the right, we have 10 plus 5, 15. So 3x equals to 15. Divide by 3 on both sides, you get x equals to 5. Let's try this on the equation given on the right hand side. Okay, the denominators are 2 and 7, right? What is the LCM? 14, right? 2 and 7, LCM is 14. So let's multiply by 14 on both sides. On the left, 14 divided by 2 is 7, and on the right, 14 divided by 7 is 2. Correct? So we multiply the left hand side bracket by 7 and the right hand side bracket by 2. Let's see what gets. 7 times 3x is 21x. Take away 7 times 4 is 28. So 21x minus 28. And on the right, we have 2 times 9x, which is 18x, minus 2 times 5, which is 10. Right? 18x minus 10. Should be easy from this point onwards. It's like unknown on both sides. So let's eliminate the 18x on the right, bring it to the left. Subtract 18x from both sides. On the right, 18x minus 18x is 0, so you're left with only minus 10. On the left, we have 21x minus 18x, which is 3x minus 28. 3x minus 28 equals to minus 10 on the right. Let's get minus 28 on the right hand side now. Inverse of minus is plus 28, so you add 28 on both sides. Minus 28 plus 28 on the left is 0, so you're left with 3x. And on the right, we have minus 10 plus 28, which is 18. 3x equals to 18, you can see the answer now. X equals to 6 divided by 3, right? So we solved a lot of difficult equations, but then we used some simple basic principles to solve these difficult equations and still get the answer, right? Three things that we learned in this lesson. First, how do we solve equations having unknowns on both sides? Then we learned solving equations involving brackets. And finally, we also saw equations involving fractions. Fractions on same side of the equal to sign, fractions on both sides of the equal to sign. So we did a lot of complicated equations using some basic principles. I hope you liked the session and you understood everything that was taught in this lesson. Thank you.